last year I was at a major machine vision conference and an executive came on stage and he said, camera hardware is dead. It's all about software now. Today, I'm about to tell you the exact opposite is true. With the advancements of AI, specifically vibe coding, software is getting commoditized and hardware is becoming more important. So I'll show you how that can help you in the work that you do. So in the next 30 minutes, we're going to build a working machine vision system live on stage from 0 to 100. And then I'm going to give you a framework that covers every machine vision problem in the industry. And then I'm going to leave you with tools so you can also hit the ground running. So when I talk about AI in factory settings, the number one pushback that I receive is this. Sure, you can hack together a demo, but can it actually run 24/7 on a production line? Now, I will answer this question in two ways. Number one is AI software is already everywhere. If you look at Anthropic, which is the fastest growing company in human history, 70 to 100% of the code is written by AI today. This is happening already. And the cars that you drive every day, I'm pretty sure that you know most of the parts have been inspected by AI. So AI is already have an effect in our lives and in businesses. But the best industry for AI coding, in my opinion, is machine vision. You know why? Because you don't buy a product or a software and put it on the factory line the next day. You actually buy or get a product or a software. It could be brilliant, could be awful. You validate it. You go through design and processes. It could take weeks, months, years. And then only if it passes your validation, it goes to production, right? So the validation process doesn't care who wrote the code. It cares whether the code passes the test or not. So the real question is not, is AI code reliable or not? Because you will test the crap out of it anyways. The real question is, who do you want to own the code that passes your validation? And this is what I'm going to spend the rest of my talk about. Let's get to the vibe coding part. So I have a turntable over here, and there's a Teledyne machine vision camera. It's a 5 megapixel camera looking at it. IMX264 for the ones who actually care. Okay, I'm going to be using GitHub Copilot CLI. It's very similar to Cloud Code, if you guys are familiar with it. And I'm going to start with the basics. I'm going to choose the model that we want to run with this. I've already chosen Opus 4.8. It may be a little overkill for what we have to do right now, but GPT 5.5 is also enough. Usually you have to have an orchestration layer where the 12 models basically create the PRDs and then assign the tasks to low-level models to do. So, but I don't want to take any risks for this demo. So I'm going to just choose Opus 4.8. Medium or high, it doesn't really make a difference. Okay, and then I'm going to allow all permissions. Not recommended at all. I just don't want the code to disrupt my presentation. There are so many better ways. So when the code is working, if it has to take an action or, like, for example, edit a file or delete a file or whatever, it will ask for permissions. I'm going to allow all of them. I'm willing to take that risk. You shouldn't. There are so many better ways to do this. You can create permissions based on what fits your needs. So I'm going to allow all. Okay, perfect. Now I'm just going to say a basic prompt. I have a Teledyne machine vision camera connected to my computer via USB 3. Build a simple acquisition with basic controls. Okay? So here's the framework that I wanted to talk to you guys about. So I had my AI agents work through every machine vision application in the industry. And every machine vision problem can be categorized in 5 fundamental tasks. Number 1 is classification. Basically, classification is what category is this? What am I looking at? Second one is anomaly detection. Anomaly detection is something wrong. Basically, anomaly detection is the opposite of classification. It's what classification is not, right? The third one is measurements. So this is measuring how much in actual real units. It could be areas, it could be dimensions, it could be angles, it could be temperature, any sort of measurement. The fourth one is decoding. What does the symbol say? This could be text decoding, object character recognition, QR code decoding. So the fifth one is localization. Where is it, right? So you find it, but where is it on the frame that I'm looking at? So if you master these 5 image processing tasks, you can solve any machine vision problem in the industry. Essentially, that's it, these 5. Let's go through some examples. Electronics, PCB assembly. So you have to localize the components, essentially. You have to verify it, and you have to decode the chip. What part is this? Is this the correct part that has to be there? And you also have to detect the soldering bridges and everything. Pharmaceutical, same thing. You localize the pills, you count them, and you decode them. Body panel inspection, same idea. It just adds measurements to it. So every machine vision task is basically a combination of 1 to all 5 of the 4 core fundamental tasks that I talked about. The right way to program with AI is to start with a PRD, product requirement document. The more time you spend on the PRD itself, the better the AI coder is going to work. So I would say majority of the time, because if you want to go back and forth between the AI coder to add or subtract stuff from what it created, it's going to take a lot of tokens, and there's this concept of token drift, which means the more you talk to AI in a specific session, the more stupid it gets. It keeps on forgetting stuff. So getting the PRD right the first time and spending time on it is actually the recommended method here. Okay, so it finished. I'm gonna say start the app and monitor the output. I'm gonna do this because if the app fails, hopefully it doesn't, then it can debug in real time. I don't have to copy and paste the errors. Okay, first step, good job, baby. I'm proud of you. So let's actually make it more complex. Oh, it says the app exited cleanly with code 0, no errors. Good job to you. So let's add a data matrix code counter, right? And add a live scoreboard so we can actually see the number of matrix codes that it counts. And make sure to auto adjust camera parameters, not just brightness, until the code can be read. So back to this question. Who do you want to own the code that passes your validation? Now, the main reason to think about AI coding is IP ownership. So right now, most of the tasks that we do on a daily basis, we're working with exclusive vendors. We basically put our wrappers on top of those vendors. We're making their software better. But with AI coding, what that allows you is for you to own your IP. So basically, you go from being a reseller to being a solutions company with exclusive technology. That's a huge difference. And this is the best time in history of software to actually do this. Let me go through 30 years of tech cycles. 1995, dial-up. I hope some of you remember dial-up. Anybody who wanted to have software or had anything to do with software, they would build it in-house. That was the only way to do this. Then came the Agile and .com, everything went on World Wide Web. Then came the SaaS, software as a service. Basically, companies came in and said, why are you spending all of that CapEx to build software that is not directly aligned with your core values? The core value that you're providing your customer. We're going to build that software for you and charge you on a service basis, on a monthly, yearly, recurring fee. So SaaS was born. And then everything went on cloud. Basically, mobile APIs, and you could work anywhere. Your tools were available anywhere you were. And now in 2025, we are back at square one, where with AI, you can actually build software in-house now. And in each of these cycles, the cost of using or writing software collapsed. So this is the prime time to actually think about building software using AI code with the tools that are available to us. At some point, I don't know if you guys remember, but Cloud Code actually, they eliminated these verbos. So it wouldn't show you anything. It was very minimal. And that really pissed me off. It pissed off a lot of developers. And they brought it back. So I'm happy we can actually read what is out there. Yeah, we have built a lot of tools around our machine vision products. So AIs can really connect to them cleanly and test them in real time. So it will go through some validation as it's doing its job as well to make sure stuff are working as expected. Yeah, this is why you need a BRD. Because if you just throw a prompt at it, it will do stuff that I really don't care at this point. Like I don't care if you're widening the window or not. So, like it's doing UI stuff. It's doing the reader panel builder, which is great. Actually, as this is working, any questions you guys have? We have time now.
How much is it like costing? Do you know?
That's a good question. Let's see if it can give me the context as it's working. Yeah, so you can see if you go to the /command context, and different platforms are different, but you can see that it's using tokens. 73,000 tokens were used on Opus 4.8, which is crazy expensive. It's not giving me the cost. I mean, thanks to our IT team for blocking that. Yeah, but I would assume this is going to cost, I don't know, about $5, $6 for the whole thing. Yeah, because Opus is like $1 for every million tokens. Yeah, at the end, it's probably going to cost us about $5. So please leave it there. So yeah, any questions? We had a lot of questions. I love it. Yeah, go for it.
What is this?
This is actually the CLI that's Copilot built. Yeah, so you can use the Copilot as you see here, as the chat session over here on the side. Like you can just start chatting with it, or you can run the CLI. CLI is like the command line interface, which is like Cloud Code. The reason I personally use the CLI more than the actual chat box is because it allows for parallel agents to be run together. Like with the UI, it's just one agent per session because it has to control the UI. But with the CLI, you can actually have multiple parallel agents. It gets very complex though. Like I don't suggest parallel agents unless you actually know exactly why you're doing it, because it gets complex and it gets very expensive. But that's basically why I'm using the CLI. I'm kind of used to it. Any questions? Yeah, go for it. Yes. We have a set of skills that makes it easier for you guys to integrate into our cameras. Like we're making our cameras AI ready, in a sense. Yes, great questions. Thank you. Any other questions at this point while the AI overlords are spending our dollars? Yeah, and it's getting more expensive as time goes by, so.
So why would you host this application with the camera? Would you have a PC next to it, or?
It really depends on the environments that this is being run in. So you could live on a computer, it could live on a host PC. It really depends on the environment. You can host it anywhere, essentially. Right? And you can tell the AI, this is part of the product requirement document, you can tell the AI that I want to host it on Linux or Debian, this box, and it will make sure the code can be compiled in that environment. So you can host it basically anywhere.
Is there an advantage to host it on one of those NVIDIA embedded GPU PC things and all that?
If you are doing machine vision or you're running models, those NVIDIA chips are really good at inference on those models. Yes, yeah. But if you're doing basic stuff that doesn't really require that level of inference, you can run it on any computer. Yeah. Yeah, but NVIDIA is coming up with really great chips that can do a lot now. Okay, thank you so much. My apologies, I got overexcited. Okay, so let's connect. Let's start the live feed again. Okay, fantastic. Let's see if we can start reading. Yes. Okay. It actually does go fast. It shows that the code reading is actually faster. Fantastic. Okay. The code is working. So I'm just going to summarize what I went through. So let's compare the old model with the actual code that you own. So in the old model, you don't own the IP, the software provider actually owns the IP. But with the new model, you own the code, you own the IP. This is your property now. Recurring costs with the old model, there's annual licenses per seat. With AI, the cost is 10 times cheaper, right? And I've seen in many companies they're actually running AIs locally on their servers now. So that even makes it even cheaper than, much cheaper than the old model. This is, I think, one of the core differences between the old model and the new model. If there is a bug to fix, or if you want to request a new feature, with the old model, you have to go to the vendor, you have to set up a call with them, create a ticket, explain the need, the feature, and that takes a lot of time. But with the code that you own, if you see a bug, or if you want to add a feature, as we're going to do right now with one of your suggestions, it's really easy. It takes minutes to hours to add stuff, remove stuff, as you wish. That's critical. That's a game changer in some scenarios. There is no customization ceiling for AI codes. You can customize it as much as you possibly want. You don't have to convince a third-party vendor that this is important to us. Data visibility. You own your code. You don't have to send samples to somebody else to debug. Data is within your company. And modularity. The old model it could be tied to a specific platform. With the code that you own, with the AI code, you can change the platform as you wish. So if Python goes from 3.12 to 3.14 or 15, you can easily come back and say, can you upgrade the Python to this? And it will do that for you, right? So you can move. The modularity is there. You can move between platforms. The only advantage I could find for the old model is you have someone to call or blame. But with your own code, you're on your own. But what I want to tell you is the one to blame is actually your validation system. If you don't have a rock-solid validation process, obviously the AI code is not going to give you the results that you need. So the validation process and the PRD that you create to create the code and test it is critical. This AI code piece in the middle is just a tool. So basically, hardware isn't dead, it just got more important. When software becomes almost free, the quality of the image becomes the entire game. And with Teledyne, we help you go beyond sight. We are using AI in everything that we do, and we are making our products AI ready. So other companies can actually fairly easily code using our products. And we're the frontiers in that domain. Yes.
So if you're a startup, AI startup,
Yes.
how does one get involved in that? How does it collaborate?
For you, yeah, I can get your information and I'll put you in touch with our software team, and yeah, you can get in touch with us and we will help you out. Absolutely. Yeah, go for it.
How do you counteract, or what is your process to counteract misalignment? So you mentioned scoreboard, but the name, it doesn't understand what scoreboard means, and all of a sudden it adds like a whole other window and all that stuff going on another tangent, and split up what's the result that it's doing.
Honestly, I prayed all night last night. That was my strategy for this demo, because God knows what it's going to like. At the prompt I gave it was dumb, right? But in a real environment, I will actually define exactly what I want it to do. Like I would say,
The plan document.
yes, the PRD is essential. I'm telling you, like that's the first thing that anybody has to create. So. Absolutely. Sketch it on a paper, right? You don't even have to do a proper design. Like you can, but you can sketch it on a paper and attach it to this and say, this is the design I'm thinking. It will make that for you. Absolutely. Yeah, it's crazy what AI can do. You know, I wish I had this 20 years ago. Yeah.
When you're in the green field,
Yeah.
a process like this
Yeah.
tends to have more success. In the event that you're coming into a code base that already exists,
Yes.
you have that green field. How does your process of developing that plan look?
Yeah.
Validating that plan against the database?
Yes. So there is a tool that all CLIs have. You probably know it's the initialization tool. So when you open it up, you say /init, and it will initialize the code base and it will understand it for you, right? What I personally do is I have a bunch of plugins that actually help me develop new features. So one of them is called Get Shit Done. I don't know if anyone used Get Shit Done before? No? Okay, GSD, Get Shit Done. And it's really designed to it will first understand your code. It will create a bunch of markup documents to structure what is already in your code. Then you can define new features. So you can add a feature into it, and it's kind of like plan mode. It will go through questions that it has, and then you can track features. So it's really designed for software development. So I would say start using tools. There are so many great tools out there that are extremely useful in your scenario. Absolutely.
Hey, so this is all really cool, really great, scary stuff.
Don't tell me if it works on the factory line or not.
Yeah,
Oh.
so how do you, like, what is your guideline for validation, Because, I mean, like, looking at it at face value, so it's really quick.
Yeah.
Now, you said it earlier, how would I make sure this is running 24/7?
It really depends on, that's a very tough question to answer because I need to know more details about your application. It really depends on what you want to accomplish at the end, right? Like what is the end result that you're looking into? One of the features that they've added to Cloud Code, and soon I think Microsoft is going to follow suit, is the ability to set a goal. So it's you /goal, and basically what you tell the AI is do not stop until you accomplish this specific goal, right? For example, you could say, do not stop until you you can recognize this specific character, or you can count these number of items, or you can feed it like we had a Cognex system in our office, and I replaced that whole system with AI code, and what I gave it was a bunch of images, like inputs and outputs. I said, these are the inputs, this is how you have to give me the output. We were looking for screws missing in our hardware. And I gave it a goal. I said, make sure that you can spot the missing screws on here, exactly as, and these are the samples, like these are the correct ones, these are the incorrect ones. So it went through for almost a day until it accomplished that goal for me. So you have to clearly define what you want to get out of it. And when you do, it will get that to you. Yeah. Oh. Yeah. Give me a second. How should the OCR's text next to each data matrix code appear on the scoreboard? Okay, so which one should we go to? Count it separately. I'm just going to pair it with the code, whatever. Okay, thank you for showing me that. I wasn't paying attention. Yeah. Any other questions? Yeah, so one of the other things that I do when I'm working with AIs is, in addition to the PRD, and it has already, it is defined in the global settings, that's why it asked me that. Always end my prompts with ask any clarifying questions before proceeding, because I don't want the AI to assume anything for me. So any prompt that I give it, I always make sure that it is doing what I want it to do by asking you to clarify before proceeding. So that's why I kind of ask a clarified question. Because the PRD that you create comes from your knowledge of the industry, the way you look at the problem, right? So you're not building a generic model. You're not building a generic program at all. This is a generic program that I built. But if we were in an industrial setting, the requests and the needs were completely different. So I would completely build a different model that really fits that specific need. So yes, yeah, it's going to be, like, I think the number one feature of AI is personalization. Personalization means your code is going to be your own, the way you work is going to be your style. Everything is going to get personalized for us in the near future. Like, we're going to take even pain medication. Advil is generic. We're going to have our own personalized medication that fits our headaches, not everybody else's. So personalization is key. And when you get into AI coding, you will definitely personalize it for your own needs. And that will become your IP. I hope that answered your question. Yeah. Okay, thank you so much.